notes for today. I do want to talk a little bit about the balancing equation stuff that we went over at the end of last week. I know that I mentioned that it was really tricky stuff, and for the most part, you guys did a really good job of figuring it out and kind of working through some of those examples on your own. But when I was going back through and looking at a lot of the work that people were turning in, it made me realize that I really wish that we had kind of more time to sit down and talk about it and go through some more examples and talk about it in a little bit more detail. But unfortunately, with the shorter amount of days that we're meeting, while still having to cover the same amount of stuff as we would in a normal school year, we just don't have the kind of time that I would like to have in order to really go through the balancing equation stuff. So what I decided to do is that I made your 2 balancing equation worksheets essentially participation grades. So as long as you did your best on them and tried to complete them and turn them into me, then I'm just going to give you full points for getting those turned in. Again, I wish we could spend more time going through it because it is something that I think everybody can pick up with like a couple days of practice at it. Unfortunately, we just have to keep going with this online environment that we're in. So I'll probably make an announcement about it on the Google Classroom at some point. But since you guys are so awesome and on top of things and actually come to the Zoom calls on a regular basis, I wanted you guys to know first. So I think you guys have already turned in either both worksheets or at least one of the worksheets. So just know that I'm not going to be going through and taking off a whole bunch of points for any of the equations that you get wrong. As long as you turn it into me and I can tell by looking at it that you put some work and some effort into it, you'll get full points for participating in the balancing equations worksheets. So hopefully that should make you guys feel a little bit better about some of the stuff that we got going on this week. So with that announcement out of the way, today we're going to move on to something that is a lot more simple and straightforward than the balancing chemical equation stuff, because we're kind of going to start to move into the direction of more of the P side of IPC versus the C side. So the first several weeks of class were really focused on the chemistry aspect of stuff. That's all the stuff with the atoms and the types of matter and the reactions and the bonding. All that stuff is essentially chemistry. Now we're going to start to move into physics, which is a branch of science that deals with how things move, either if they're super tiny, like little atoms or molecules, or if they're big and giant, like planets and stuff like that, when we're dealing with astrophysics. So today we're going to take our first little baby step towards the world of physics by talking about some of the different ways that scientists measure things. So we can go ahead and pull up our Google Classroom. Where is it? There it is. This one, please. Oh, there's Alicia. All right, so just like all of our other notes, I'll be recording our meeting today. And then once we're done here, I'll go through and post it in the section for today, 10-6. So today is all going to be about scientific units, also known as SI units, for International Standard Units, except the actual name is in French, which is why the letters get switched around. So we are in week 6 of this class, which seems crazy to me. So once we're done with this week, we're only going to have 2 weeks left in term 1, which to me, it feels like we just started. So I can't believe we're almost to the end already. All right, SI units and conversions. So like I said, today we're going to be talking about how scientists measure things. And so you might think that, oh, we're in America, we use what's called the imperial system. So we like to measure things in feet and yards and pounds. So that must be what American scientists use too. Actually, that is not the case. Instead, scientists, so that all scientists around the world are using the same measurements for their experiments and the research, scientists use the SI units, which are also known as the metric system. So today we're going to talk about the metric system a little bit, how it's used to measure different types of objects, how it compares to the system we use in the United States, the imperial system. And finally, and probably most importantly, at the very end, we're going to talk about how we can convert between different sizes of the metric system. If we're measuring things that are really, really big or really, really small, how can we switch between using those measurements? All right, so first up in our metric system, our standard units, we have the measurement of length. So in America, we use things like inches and feet and yards and miles in order to measure how long something is. But the metric system uses something different. They use things like meters, centimeters, and kilometers. So a mile in the American system is longer than a kilometer. So 1 mile is about 1.6 kilometers. A meter is slightly longer than a yard. So by about a few 9 or 10 centimeters or 3 or 4 inches, a meter is longer than a yard. And then if you've ever looked at one side of like a ruler, one side is usually in inches and the other side is in centimeters. And you may have noticed that inches in general are a little bit longer than centimeters. So 1 inch is about 2.5 centimeters. So in science, in scientific research, we use the metric system, which means we talk about things in kilometers, meters, and centimeters. And if we go even smaller than centimeters, we have things like millimeters, which are all of these tiny little dashes on the ruler down here. These little guys are all millimeters. So in the metric system, you may have noticed that the base unit of all the different measurements I was describing is the meter. So we have 1 meter, 1 kilometer, 1 centimeter, and 1 millimeter. And so a kilometer is bigger than a meter. If you put 1,000 meter sticks together, that would be the length of 1 kilometer. And then a meter is longer than a centimeter. So there are 100 little centimeter ticks on the meter stick that we were looking at a second ago. And a meter is much longer than a millimeter. So a meter is 1,000 millimeters. So all those tiny little dashes on our ruler, on our meter stick down here, there's 1,000 of these little dashes on a normal sized 1 meter long stick. So one of the great things about the metric system that you may have noticed is that everything is based on tens or hundreds or thousands, which makes it really easy to convert between kilometers meters, centimeters, and millimeters. So unlike in the American system, where we have 5,280 feet make up a mile, but there's also like 1,370 something yards is a mile. And then there's 12 inches in 1 foot. And then there's 3 feet in 1 yard. All those measurements are all over the place. 12, 5,000, 1,000, 3. They're all kind of hard to keep track of. Whereas with the metric system, it's super easy. How many meters are in a kilometer? Oh, there's 1,000 meters in a kilometer. How many centimeters are in a meter? Oh, there's 100 centimeters in a meter. And because there's 100 centimeters, 1 centimeter is 10 millimeters. So there's 1,000 millimeters also in 1 meter. So very easy to switch between the different measurements. And that's something that we'll talk about in the last couple slides of the presentation today. So like I was just saying, in 1 centimeter, there are 10 millimeters. So in 1 centimeter, there's 10, and 2 centimeters, there's 20, and 3 centimeters, there's 30. So in a meter, there's 100 centimeters, which means there's 1,000 millimeters. We just add an extra 0 on because we're just multiplying by 10. So if we're looking at this blue line, blue line down here, and we wanted to measure it with centimeters and millimeters, we could go by centimeters. So we could say it's 1, 2, and then it's not quite 3. So we have to go to the smaller counts. This would be 2.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 2.8 centimeters in this blue line. Or if we counted up all the millimeters, it would be 28 millimeters. So whether or not it's in centimeters or millimeters, we still have basically the same number. It's just either 2.8 centimeters or 10 times that amount, 28 millimeters. All right. Any questions on meters and length in the metric system?
No.
All righty, awesome. So up next we have mass, or how much something weighs, how we measure weight in the metric system. So again, we're not going to use our normal English measurement of ounces or pounds. Instead, in the metric system, we have things like grams and kilograms and milligrams. So grams are pretty small, right? There are 450 grams in a single pound. Kilograms are a little bit closer to pounds, but they're about twice as big. So 100 kilograms is 220 pounds. So if you ever meet somebody from England or from Australia or something, and you're talking to them about weights, and they mention that they're 100 kilograms, that doesn't mean that they're super crazy skinny, because they're not talking pounds, they're talking kilograms. And so a kilogram is about 220 pounds. The way I normally think of a kilogram, and I don't know why, but I think somebody used this as an example once and it just kind of stuck, is if you think about like a big textbook that like your kids get from their school, or that you used back when you were in high school, like the big history book or a big math book, those are about 1 kilogram. So a kilogram is pretty sizable, fairly heavy. And then obviously if grams are small, milligrams are very, very small. So just like you probably picked up on with the meters, our base unit of mass of weight in the metric system is the gram. So whenever things get measured out by grams, we're measuring their weight using the metric system. And then again, just like with our measuring, it's all based on units of 10 or units of 1,000 if we're going up a couple each time. So 1 kilogram is the weight you get when you put 1,000 grams together. And 1 gram is what you get when you put 1,000 milligrams together. And I just realized there's some typos on this page. So the symbol for kilogram is not km, it is kg. And then the symbol for gram is g. And then the symbol for milligrams is mg. So kg, g, and mg. Kilogram, gram, milligram. All right, so again, very easy to convert between the different sizes of units. If you're going from grams to kilograms, you just multiply by 1,000. If you're going from grams to milligrams, you just divide by 1,000. All right, so up next is volume, which is just a measurement of the amount of space that something takes up. So this would be like when you go to the store and you want to buy a new desk or a new dresser or something, and you were looking for a dresser that's 3 feet wide by 2 feet deep by 6 feet tall. Those measurements are what tell you the volume of that furniture, that dresser. So in the metric system, a lot of times we'll measure volume by its liquid. So how much liquid space does a certain thing take up? So in metric units, we don't have fluid ounces or gallons or like half gallons or anything like that. Instead, we use liters. So a liter is pretty close to a quart. So a quart, if you remember from your elementary school science, is a quarter of a gallon, so 1/4 of a gallon. And so a liter is really, really close to a quart. It's about 1 quart is 0.946 liters. So we can also use milliliter. Man, I really got to double check my typing before. This isn't milligram, this is milliliter. So we have liters and we have milliliters are probably the two most commonly used measurements of volume in the metric system. Technically, you could measure things in kiloliters, but that doesn't happen as often as liters and milliliters. So if a liter is only about 1 quart, a milliliter, which would be 1/1000th of a liter, is really, really, really small. Whenever I think of a milliliter, I think of like a single raindrop, or like if you're putting like eye drops in your eye, the amount that comes out when you just do one little drop, that's approximately 1 milliliter. So if you did 1,000 of those little drops, you would end up with 1 liter. So 1 fluid ounces, which is what we use a lot for liquid measurements in the American system, is about 29.5 milliliters. So in your single can of soda, like a normal can of Coke or Diet Coke or something, that there's about 355 milliliters in that can. If you want to think about like the scale of the milliliter. So milliliters, very, very small. But then on the flip side, it would take about 2.5 cans of soda to make up a liter. So volume, again, the space that a system takes up. We normally represent liter with either a capital L or a lowercase l. Usually a capital L, just because that makes it easier to distinguish that it's not like a 1 or an I or something like that. So liter is used a lot for liquid measurements. But if we're talking about solid measurements, solid volume, we can also measure things by what's called cubic centimeter. So if you had like a tiny little block that was a square that had 1 centimeter on each side, then you could say that block is 1 cubic centimeter. So you don't really have to know too much of the difference between liter or centimeters cubed. Just know that they're both used to measure volume. So again, in 1 liter, we have 1,000 milliliters. So if you have something in liters, you can multiply by 1,000 and that'll tell you how many milliliters are in it. Or if you have something if you have a lot of milliliters and you want to convert it to liters, you just have to divide by 1,000. And up next, we'll go through a whole bunch of different examples of converting between the different types of measurements, or like the different levels of measurements. All right. Any questions so far on our different types of metric measurements or SI unit measurements? Any meter, gram, or liter questions? All righty. So that stuff is pretty simple, pretty straightforward. But the big thing that I wanted to go over with you first with those things before we get into this next part is that the last section of today, we're going to talk about converting between our different units. So between kilograms and grams and milligrams, or centimeters and millimeters and kilometers and meters, or liters and milliliters. We're going to look at a really simple and easy way to change from one type of measurement to another one. And it's called the ladder method. So in the ladder method, here are all of the different kind of types of measurements that are all arranged around the basic unit, right? So we talked about how we have meters for length, liters for volume, and grams for weight or mass. And so all of these different prefixes, these different little steps on our ladder right here, are all different types of measurements based on either meters or liters or grams. So a lot of these will probably look kind of weird to you, and honestly, they don't get used very often. So the two most used types of measurements besides the basic unit are our kilo measurements, right? So we had kilometers and kilograms. And also on the complete other side, the milli measurements. So we had millimeters, milliliters, and milligrams. We also talked about centimeters when we were talking about measurement. So that guy that's about 2.5 of these fit in 1 inch. And then honestly, deci, deca, and hecto aren't really used all that much in scientific lingo. We kind of gloss over those three because usually scientists like to stick to our kilo, our milli, or our centi when we're talking about length. So the way that we can convert between our different measurements using the ladder method is super duper simple. All right, way less complicated than some of that balancing stuff we were doing at the end of last week. So essentially what you do is you figure out what measurement that you're starting with. So if we were starting off with liters and we wanted to convert to milliliters, hold on, let's see what's a good color for today. Thinking dark green sounds good. So if we had liters and we wanted to convert to milliliters, we would start with our basic unit, which is a liter, and then say, okay, how many milliliters are in a certain number of liters? All we'd have to do is first look at our ladder and say, all right, to get down to milliliters over here, we have to go 1, 2, 3 steps over to the right from our base to our new measurement. So all we would do is then go down to our decimal place and move our decimal point 1, 2, 3 steps to the right. Now, all of a sudden, we have a much bigger number because we've converted from liters to milliliters. So say we had, I don't know, 2.6 liters. If we move our decimal point 1, 2, 3 steps to the right, so our decimal point is over here, we fill in those empty spaces with zeros. And so we can say, this is a 6 right here, that if we started with 2.6 liters, if we made that milliliters, that would be 2,600, so 2,600 milliliters. Because we took our decimal point and moved from the 2.6 and moved it 1, 2, 3 spots to the right, just like we did 1, 2, 3 jumps to the right to go from liters to milliliters. All right, so here is another example down here. So over here, we start off with 4 kilometers. So we're right here in the kilo section. And we want to know how many meters do we have in 4 kilometers. So first we have to see how many jumps does it take to go from kilometer to meter. Start off at kilometer, and those little red lines here show you we go 1, 2, 3 jumps, 1, 2, 3 jumps to go from kilometers to regular meters. So if our starting number was 4 kilometers and we moved our decimal place 1, 2, 3 spots to the right, we fill in all those spots with zeros. And so 4 kilometers is equal to 4,000 meters, right? Before we had our decimal point here, but it took 3 jumps to the right, 1, 2, 3, to go to kilo, from kilo to meters. So we'd take our decimal point 4 spots to the right, 1, 2, 3, to go from meters to, or from kilometers to meters. We can also do the same thing in the opposite direction. So say we started off with 470 millimeters. And I want to know how many meters is 470 millimeters. First thing is we have to figure out how many steps we have to move and which direction that we go. So if we start off with milliliter over here, we go 1, 2, 3 jumps to the left. So that means we have to do the same thing with our decimal point. So on a whole number like 470, the decimal point is right here at the end. So we take that guy and go 2, 3 spots to the left, because that's what we did on our ladder. From milli to meter, we went 1, 2, 3 jumps to the left. So we take our decimal point, 1, 2, 3 jumps to the left. Now the decimal point is in front of the 4, which means that we have 0.470 meters. And that is what is equal to 470 millimeters. So if you follow these steps down here, you should be able to pretty simply figure out how many of one type of unit do I have in this bigger or this smaller type of unit. So you determine your starting point. Are you starting off with kilograms or with liters or with centimeters? You count the number of jumps or the number of steps to wherever you want to end up. However many you move in a certain direction, you move the decimal point of your measurement in that same direction. So if you have to take some jumps to the right in order to go from your starting to your ending unit, you move the decimal point to the right, just like we did when we went from kilometers to meters. Same thing if you're moving your jumps to the left, like when we went from millimeters to meters, then you're going to move your decimal point that many jumps to the left as well. All right. I know we had a couple people join us kind of partway through, and so don't worry, we're going to look at a couple more examples of this in a second. But anybody have any questions so far? Anything that I just did, they're still not really sure what exactly I was doing or what it meant? All righty, not hearing anything right off the bat. So we'll look at a couple more examples of these just to kind of make sure you guys are all set. And then we'll wrap it up for today. All right. So let's check these examples and kind of see how they came up with the numbers that they did. So some of these are pretty simple and straightforward. Okay, here's a good one. They're saying that 160 centimeters is equal to 1,600 millimeters, 1,600 millimeters. So let's see how they got there. So here is our centi units right here. And so we have centimeters. And so that's where we're at. So we got 160 of these guys. And in order to get from centi to milli, we have to do one jump to the right. So if we have 160 centimeters, and we take our decimal place and move it one jump to the right, we fill in that new open spot with a 0. And so we can see that indeed 160 centimeters gives us 1600 millimeters. All right, all we had to do was take one jump to the right. So we moved our decimal point one jump to the right. And so that gave us our 1600 millimeters. All right, let's see another good example. 109 grams to kilograms. So we have 109 grams. And so remember, the gram is one of our basic units right here. And it's saying we need to turn this into kilograms. So kilograms are way up here. Kilograms. So first off, it looks like we need to move to the left. And we're going to move to the left 1, 2, 3 jumps. So we need to take our decimal point 3 jumps to the left. With 109 grams, our decimal point is right here. So 3 jumps to the left, 1, 2, 3. So it's saying we should put the decimal in front of the 1. And so we have 0.109 kilograms. All right, and if you want, you can draw the extra 0 out in front of the point. 0.109 kilograms. So we jumped 3 spaces and we jumped to the left. So we took our decimal point and jumped it 3 spaces to the left. And that told us that, in fact, 109 grams is equal to 0.109 kilograms. All right. Let me see if there's one more good one on the next slide. Here we go. 104 kilometers to meters. So we'll go back to this side to get our ladder back. So we have 104 kilometers. So we're starting off up here, kilometers. And it said it wants us to turn this into meters, which is one of our basic units, right? So along with the liters and the grams, we also have meters as our basic unit. So got to figure out how many steps and which direction. We're going from kilometers to regular meters. So we're moving to the right. And we're going to move to the right 1, to 3 times. So we do the same with our decimal point. In this case, our decimal is at the end of our 104 that we start off with. So we're going to move it 3 more spots, 1, 2, 3, to the right, because we had to move 1, 2, 3 jumps to the right on our ladder. So we fill in the zeros in those empty spaces that we just created. And we can see that 104 kilometers gives us 1, 0, 4, 0, 0, 0 meters. And then here is our decimal point at the end. So 104 kilometers is equal to 104,000 meters. Luckily, that checks out because we've already talked about how there are 1,000 meters in a kilometer. So in 104 kilometers, you should expect there to be 104,000 meters. All right. So that is pretty much everything you need to know about metric system units and how to convert between them. Does anybody have any questions about the conversions or the units?
No.
All righty. So your first couple is, whoops, I forgot that it leaves all that stuff on there. There we go. So your first couple assignments for this week should be pretty simple. The assignment for today, it just asks about the units, so the different types of meters and kilograms and milliliters and stuff like that. So there are a lot of questions, but they're all super simple, and they come in a couple different sections. So up first is just has a series of units, and I want you to tell me what type of measurement, whether it's length, mass, time, so they include time on here, which is used just like in the metric system like ours. There's seconds and minutes and hours. So length, mass, time, and volume. So based on the symbols, you should be able to figure out which unit is this talking about, and then is that a unit of length, mass, time, or volume? So we have things like ml, s, g, L, all sorts of stuff like that. The next section is flipped around, where it gives you some of these common measurements that we were just talking about with the kilometers and the grams and the millimeters and centimeters. And all I want you to do is indicate its symbol, which is like these guys. So the 1 or 2 letter symbol that represents milliliters or kilometers or seconds. And then finally, the last section has a couple of different real world items in it. And it's up to you to kind of match the item with the unit that would most likely go with it. So like Coke, you can buy it in 2 or 3 what bottles? Do they come in kilogram bottles? Do they come in millimeter bottles? Do they come in liter bottles? Stuff like that. Ask you the mass of a bowling ball, how big a fly is, how much volume is in a teaspoon of cough syrup. So stuff kind of like that. So some basic questions just dealing with some of these different units that we've been talking about today. So that one, pretty straightforward. The next one is a teeny tiny bit more difficult, just because this one has to do with those conversions that we were just working on a minute ago. And so there is a whole bunch of these different conversions, but it should take you pretty quickly because, again, it tells you your starting unit and it tells you what you're going to. So all you have to do is pull up that ladder, that unit ladder, which you can either write down your own copy on a piece of paper or on the notes for today. So the 10-6 Tuesday notes, SI units and conversions, that's what we were just talking about. I posted a single slide that is just the ladder handout. So if you want to have this up on your computer as you're working, if you want to write it down on your own piece of paper, if you want to take a picture on your phone and go off of that picture, whatever you want to do, however you want to use it in order to figure out how many grams do you get if you have 1,000 milligrams? How many meters do you have if you have 14 kilometers? How many liters do you have if you only have 75 milliliters? So you're going to use it exactly like we were just doing. Figure out your starting point, figure out what you're converting to, count the steps and the direction, and then do that many jumps in that direction with the decimal point on the starting value. All right. Any final questions about the SI units, the conversions, or the assignments for today and tomorrow?